To begin with, I wanted to lay out the foundations for this project, and the best way in my opinion to do that was to create the level to begin with, grey box it, and then have some form of baseline to then work on the actual assets or mechanics or any other asset that may be needed. To greybox the scene, I used the Unreal Engine's geometry tool and proceeded to get the base measurements of the warehouse set so that I had a baseline for all the other assets within the level and scene so that they would fit within the main warehouse itself. I tried to stick to the closest measurements of meters. For example, I would try to stick with meter by a meter crates or a meter and a half, but I wouldn't really use a small measurement like 123 centimeters, as that is a bit out of the ordinary to say the least. I wanted clean and precise measurements to say the least. After taking into consideration the player's height and how tall they are compared to other actors such as the shipping crates, I was then able to establish the height of the warehouse itself. The height is 2,000 centimeters or 20 meters, with a width of 5,000 centimeters or 50 meters, with the double of the length of 10,000 centimeters or 100 meters, using a 2-to-1 ratio with the width and the length of the building. The walls themselves are 20 centimeters thick or 0.2 meters. The reason I chose these measurements are they're nice and clean measurements to use, and are very easy to incorporate with other actors and meshes in this project. After establishing those three parameters, I then moved on to working on the roof. I wanted to have quite a dynamic range of lighting within the scene so that the light itself can be seen through the ceiling of the level. For this, I created a vast number of skylights that go along 3 vertical arrangements on the roof. There are 2 that are elevated, and then there is 1 that is incorporated into the roof itself. These additional bevels are 1,000 centimeters or 10 meters high and provide an extra layer of detail and texture to the scene that would be otherwise a square building. From there, I then created the 2 airlock tunnels that connect to each other and connect the hangar to the warehouse proper. These were created using the simple box and cylinder geometry tools and changing the amount of sides on the cylinder to only have 8 in total. From there, I was able to convert them to static meshes and then be able to create. My terminal system is inspired by Fallout 3, where the player has to interact with the terminal, walking up to it and engaging. Then they have to select the correct words from an assortment of randomly generated words, numbers, and symbols to unlock the terminal. If the player is successful, they then can access the console and progress accordingly. Originally, I tried to make my terminal have a similar function to the original IP I used as inspiration of randomly generating text each time the user interacted with the terminal and displaying this text on the screen accordingly in different buttons for the player to select. However, when I tried to recreate the terminal for this project, I tried getting a random integer and displaying this on a button, then that would then be applied to each of the buttons in the grid, but it would constantly keep getting random integers for each of the buttons, so it would constantly keep ticking down, and I couldn't figure out how to make it only get one number at a time and display this number accordingly, so I had to redesign the terminal. The redesign involves switching to a username and password, similar to an old analog computer system, which has to be filled in to a preset password and username that is set for each one of the categories of the player terminal, and the player has to press the break code button. Then a line of code/words would appear, and the player will have to try and figure out which one of the 2 words from that line of words is the correct ones, and they will have to fill it in the username and password. If they get the 2 words correct, then they will be permitted to use the function attached to the puzzle. There are 4 different functions the player can use, and 4 different puzzles with their usernames and passwords respectively. These are the electric crates, containers, the electronic footlockers, the shipping crates, and the electronic grates. All four have their own unique puzzle set of different usernames and passwords. More than half of the assets were created using the geometry tool, mainly using the cube and cylinder brushes. From there, I edited the parameters of the cube and cylinder brushes to the desired dimensions that I needed. Generally, they use the centimeter ratio, so it's quite easy when converting building sizes. Standardly, I use 3 meters for each floor height. Setting the parameters is a lot better than scaling different size cubes or cylinders as developers in the past would have. This is because using the brushes, the cube and cylinder, it keeps the UVs and the dimensions intact, and this way I can quickly and effectively whitebox and lay out the level more efficiently. Furthermore, using the geometry tool allows me to use each face on the brush to be set with different materials. For this, it can be extremely advantageous when using multiple brushes. For example, a door would be combined of 2 brushes. One additive to set the size of the door, then one subtractive brush for the cookie cutter door. The 2 brushes there will have their assigned UVs and faces, so the inside of the door, which is comprised of the subtractive brush, can have its own element for a material that is separate from the rest of the door when converted to a static mesh. To construct a room, I have 2 methods. To create the room using an additive box brush, then duplicating the brush, and then to change it to a subtractive brush. That size has to be reduced then by 20 centimeters along the X, Y, and Z axis. This isn't too bad because then the walls, floor, and ceiling have a thickness of 10 centimeters all the way around. Then applying the door as before, making sure that its values is higher than the room, so they were created after the room, would then subtract from the walls and create a nice standing door. The second is how I created the main warehouse itself, which is created by individual walls, floors, and ceiling parts. Because creating a room that size would be quite problematic with the lighting if I was to do the first way. Furthermore, I have created assets in 3ds Max such as the shipping crates, pallets, and ship. The shipping crates comprise of different static meshes that have different level of details respectively. From this, I have created 5 different blueprints with 5 different LOD standards. The first is the shipping basic low. Box brush converted to a static mesh that is the same size as the shipping crate made in 3ds Max. This has a super low poly version that consists of only 6 polys that I can fill the scene indefinitely with without worrying about performance. It also selects its own material upon begin play from a simple piece of code inside itself that selects one of 4 materials that is in an array of materials and adds a great variety as each individual shipping crate will pick its own colour from the 4 so that the scene has a wide variety of different crates. The second is shipping crate low door front, using the base low poly version of the shipping crate with the addition of doors on the front of the shipping crate. This is intended to be seen by the player within a stack of shipping crates so that the back doors are not needed, but it is not interactive. Thirdly is the shipping crate low. It's the same as the previous blueprint, but it has 2 sets of doors, one on the front and one on the back. This is also intended to be seen by the player individually or within a stack itself. This is intended so that the player can see both the front and the back if they choose to, and the shipping crate is not just up against a wall, otherwise the back doors shouldn't really be there because the player wouldn't really see them, so it's just creating more polys in the scene that is not necessary. The fourth blueprint is using the highest level versions of the static meshes for the shipping container. They are used throughout the scene for the player to explore and look inside, as the doors have to be opened before begin player by me or any of the other level designers, so that the player can actually explore inside the shipping crates, but they can't interact with it or open the doors themselves. And finally, the shipping crate. As mentioned before, the blueprint uses all the highest quality versions of the assets, but this shipping crate can be interacted with by the player. The player has the ability to unlock the shipping crate as the same as the electronical crates and lockers using the terminal. Once they unlock it using the terminal, they have 30 seconds to unlock as many crates as they want to or explore inside. Before then, their timer runs out and they'll have to use the terminal again to unlock the doors. This means that if the 30-second timer runs out and they are inside the shipping crate, they will be locked inside until they access the terminal again and crack the code and let themselves out. However, having a large quantity of the blueprints in the scene has caused problems. With these 5 blueprints, the scene was filled with the blueprints with a good variety of each. On the dock and in the warehouse, there was a large clusters of the shipping crates, which was causing problems with frame rate drops going from 120 frames to about 60 when in these largely populated areas of shipping crates. From there, I selected all the blueprints and converted them all actors to static meshes. This turned them all into one static mesh that is easier on the performance and rendering and does not have so many blueprints in the scene at once, all contradicting with each other and trying to vie for power. Especially so when there are a few hundred shipping crates in one area. I used the possession node heavily in 2 blueprints, the car and in the ship. The car can be spawned by the player by pressing Z, and then the player can possess the car by pressing E or interacting with the car. This allows the player to explore the map in a faster manner, but is optional in breaking into the tombstone. There are 3 ways into breaking into the tombstone, locked strong room. There are 2 small vents on opposite sides of the walls that the player can use the car to drive in and unlock the unlock sequence, or they can use the great terminal system, unlocking it and climbing in through the roof. Unlocking the door for the player so that they are able to pick up the keycard to open the hangar. The second main way I use the possession tool in the project is with the ship. When the player is able to fix the ship fully and unlock the hangar, they will be able to get into the cockpit of the ship and finish the game. Once the player overlaps with the collision box and has completed all objectives, the player will then be able to possess the ship, which will trigger a sequence of the escape sequence and complete the game.